Hello. So I love how every time I give a 2-minute warning, it means everyone make a beeline to the seats, and then in 30 seconds, y'all are ready to sit down and ready to get started. So thank you for that. Good afternoon, everybody. Welcome to Galvanize. How many of you are here for the first time? Nice. Welcome, welcome, welcome. Thank you so much for taking time out of your day, everybody, to join us. For those of you that haven't been here before, I want to welcome you to our space. Galvanize is a learning community for technology. So it is our mission to make technology education accessible to everybody. And we do that through several programs. We have workshops here, we have entrepreneurs that work out in the space, and we have these incredible immersive programs that you see today that you're here to witness. I'm really excited to present this particular cohort and their capstone presentations to you. These folks have been slaving away, working super, super hard on these projects for the past couple of weeks. And I'm really excited to see what they show you today. Before I do that, I'm going to introduce Kara Lee, who is our Partner Relations Manager, who's going to introduce the fantastic panelists that we have today.
Hi, my name is Kara. I've probably met a lot of you at this point. I'm the Partner Relations Manager here, meaning I work on the careers team, trying to establish and bridge more connections with companies that are hiring. Part of what I get to do is put together a fantastic table of panelists to really make this presentation experience different one, a much more interactive one. So that said, if I pass along the mic down, maybe each of you could just introduce yourselves briefly. Everyone should be able to see their bios at the front of the booklets. But yeah.
Hi there, Joshua Greeno. Apparently short on words in the bio, but I've been in Silicon Valley for 20+ years, kind of grew up here and been in software for a very long time. We do a bunch of stuff at our company around OCR extraction and then also looking around different machine learning models for market context.
Hello, everybody. I'm David Von Dolan. I work at Audi VW Group, working on different projects all along the value chain for the group related to machine learning, quantum computing.
Hi, I'm Nadeep Katwa. I'm product management at SunPower. What we're doing is we have a battery business that we're creating, and essentially we're using predictive analytics algorithms as well as monitoring for asset management, make sure that we can operate these units for 10, 15, 20 years profitably.
Thank you. My name is Fei Long. I work at Dropbox. I support the data science organization at Dropbox. So Dropbox is one of the very few kind of unicorns. It's also kind of profitable, over 10 billion market cap, also profitable kind of IPO. My team supports the statistical models, machine learning models for the revenue monetization, which includes marketing, business development, and personalization. So I've been doing data science for more than 10 years. So I come from Amazon, Facebook before this.
Thank you. We really appreciate your contributions and you being here today. I would like to pass over now to Dan. Actually, just before I do that, instructional staff, please raise your hand. First of all, round of applause because you all are amazing. Second of all, if you have questions about our program, you want to learn more about the granular details, you want to grill our instructors on what they do here, feel free to introduce yourselves and meet them in the breaks and in the happy hour following. Now I'll let you take it away.
Thank you, Kara. Yes, we are definitely available for grilling about any of the questions you may have on our programs. So our data science immersive program here is a 13-week program. After the initial 8 or so weeks of structured curriculum, where the students go through intense lectures and programming exercises every day, we shift into a project mode where they spend 2.5 weeks working on a project of their own choosing. The work that they're presenting today is the result of that project mode. All of the work they're presenting is their own work. We are very hands-off. We sort of offer some suggestions and maybe some high-level guidance, but this is really their project and their chance to shine. So it's a proud moment for us as instructors because we get to see all of these wonderful people that we've been working with over a long period of time finally sort of blossom in their own particular directions. It's really cool because each of the projects is really representative of the particular individual that was working on that. So it's really fun to see. Without further ado, I'll tell you the sort of format and we'll kick it off. What we're going to do is we're going to go through 18 student presentations today. Each one's going to be about 3 minutes, and then we'll have about 3 minutes of questions. We'll do the first 9, and then we'll take a break, have a little intermission, grab some more coffee, run to the restroom, and then we'll continue with the rest of them. So it'll take about 2 hours until about 4:30. I think that covers it. Are you ready? All right, without further ado, Jenny.
Hi, everybody. Hi, my name is Jenny. My project is on predicting churn for Code Combat players. For this project, I partnered with a company called Code Combat. It's an online education company that teaches kids how to code. And they do it by playing these game levels, where they're learning how to code in Python or in JavaScript. And there are hundreds of levels in the game, so lots of opportunities for them to learn. The company is just at a point where they're needing to understand their user base more and understand their user behavior more. So the goal of my project was twofold. One, to identify users who will churn so that the company could potentially intervene and stop those users from churning and retain them as players for longer. And then 2, to uncover drivers of churn so that they can institute strategies to, in general, try to keep players for longer. The data that I used came directly from Code Combat. There was data for 160,000 players with 6 months of playing history, and then that was broken down into data on the individual levels that they played, more than 1 million levels, and the individual events that they experienced while playing through those games, 5 million events in that data set. The methodology that I used to predict churn was to think about what churn really meant for the company. Understanding when players churned at one point in the game wasn't going to be very helpful to the company. They needed to understand how players were playing through the game. And so I chose points in the game at which to predict churn and built 5 models to predict churn at each of those points. Each model was a random forest, and then it predicted that either the players would churn or what players would be retained in the game and continue to play. Each model did have predictive power. And here I'm showing the average model performance metrics. So instead of showing up for each of the individual models, averaged over the 5 of them against baseline. In the majority class, which was that all the players were churned. My models predicted about a 15% increase in accuracy, a 15% increase in precision, and they lost a little bit of recall because if you predict that everyone will churn, you have 100. So they had to lose a little bit there. A 5% increase in F1 score. The results are really important to the company because they want to understand the drivers of churn and not just who is going to churn. Drivers of early churn are a little bit different from the drivers of later churn. They rely more on, the later churn drivers were more about the experiences the users had while playing the game. And those were more actionable on the part of the company as well. So after looking at those drivers, then I have some business recommendations for Code Combat. The big one is that to retain players at higher game levels, that they could suggest practice levels both more frequently and more aggressively. So they do already suggest that players play practice levels, and that was shown in the model to increase player retention. On the strategy and use it a little bit more often, then they could see that maybe that would retain players even longer. For future work, we want to tune the number of models and the granularity of the data that's used in the features for those models, and also to do some A/B testing around the drivers of churn to see if the strategies that they institute actually pan out and do increase retention. Again, my name is Jenny, and my project was to predict churn for Code Combat. Thank you.
Questions?
I can ask a question. So here's my question. Feels like you choose a tree-based model instead of a traditional kind of logistic regression model to predict. One kind of bad part of the tree-based model is like the direction, the variable you cannot explain, which is easy to do for a regression model. So if it looks like the output of your model seems to be more insight-based than actually implementing and target based on school, why do you choose a tree-based model to start with instead of a logistic regression?
Well, I wanted to really increase the accuracy of the models as well. So I wanted to get both of those things out of it. And so to interpret the model, even though the logistic regression model is more interpretable, I could still add interpretation to the random forest model by looking at the feature importances, and then by to see to them, okay, what, in particular looking at practice levels, if the practice level rates for change for those players, how does the model change? And it did look like that one appeared to be linear, but I didn't want to be boxed into having everything be linear.
I have two questions. First question is, how did you calculate baseline? And the second one is there a natural churn rate you think is acceptable? When we talked about, it was great that you broke down kind of short-term versus long-term, but at some point, given it's a learning program, you are going to have churn, and so were you able to see kind of a good point that churn?
Yeah, so the baseline was just to predict churn at each of the points in the game that were modeled, and that was the majority class at each point, and so that's why it was a baseline. And then as far as predicting churn, so yeah, at some point in the game, either you're going to learn how to program, you're going to stop playing the game, which is good because you learn how to program, which is the real objective of the game, or you're going to get tired of playing the game. And so it would be good to go further into it and say, like, okay, well, is there a way to break up these people that leave and identify who it looks like has really mastered programming and who hasn't? But instead, I looked at primarily earlier levels in the game. There are 500 levels, and I looked at predicting churn up to 100 levels. That was the latest one. So still fairly early in the game. So focusing on people who are still learning how to code. But yeah, I think that would be one of the things to look into is like, where should those lines be drawn, and how to connect that to some more strongly to some of the business goals.
Sure. So I was just curious if you did any kind of cohort analysis to look at, whether or not there's groups within the population of players.
That was on my list of things that I thought I would be able to do. And then I hoped I would be able to do within 2 weeks. And then I realized, okay, that'll take another bit of time. Yeah. So I didn't get to do that cohort analysis, but I think that would be a great extension.
Cool. Finally, to kind of expand on that idea of good churn versus bad churn, is there anything on the business side that you saw as an aha moment for folks who have quote unquote bad churn, leaving, actually learn the program? Right? Because good churn is learning, as you say, graduate.
Yeah, so I looked early enough, like looking at 100 levels. I should specify, I don't remember if I mentioned this before, but some of these levels are played very quickly. So like a couple of minutes. And they're targeted towards middle schoolers. So this isn't really people that have already mastered coding. If you're playing out to 60 levels, you should probably keep playing some more levels as a middle schooler before you can say, like, okay, I've learned the coding. So I didn't get to dig into how good they were at coding, but I think that would be a very interesting way to extend it.
Thank you.
Thanks.
Hello, everyone. My name is Reed Smith, and I built a project for recommending maps to players of the video game OSU. So I'm going to start out by talking a little bit about how the game is played. The objective is essentially to click on a bunch of circles. So this is a mouse cursor, and this is the approach circle. And when the approach circle reaches what's called the target circle, it's time to click. And then we move on to the next one, and so on and so forth. So here's that at full speed. And just for a little context, that's an 8-star map. I play at about 4 stars. So that's kind of typical for a user who spent some time with the game but hasn't really mastered it. So my goal was to recommend maps to players that would make their sort of performance appear better rather than actually increasing their skill level. So you can recommend maps to players that will be based on their particular fields of skill increase, their fields of high skill. Rather than sort of playing to their weaknesses, you play to their strengths, and then their performance, their performance increases. So OSU's had nearly 11 million users over the life of the game. There's about 10,000 online at any particular time, and there have been almost 7 billion ranked plays of the game. So my data was 2.2 million samples of those plays, which ends up being the highest performing 50 maps from about 113,000 players. And I also have data on those players and data on the unique maps from that set. So I tried to implement collaborative filtering, but I ran into runtime issues. So I tried to do some dimensionality reduction, but my data was very, very sparse. If there's no data, there's nothing to learn. So this is a sample of how sparse my data was. So I had to shift my focus a little bit. So I discovered this tool called OSU Search, which is essentially a filtering engine based on these parameters. So this is a screenshot from their website. These sliders are essentially what I was trying to control and use to recommend maps. And then these are some recommendations. And this is the homepage of my app. And this is where it's deployed. My name's Reed Smith. I did a project for recommending maps to players of the game OSU. Thank you. Any questions?
So, nice job. The first kind of question that comes to my mind is, when you're dealing with sparse data and you're building a collaborative filtering system, would there be any other opportunities for looking at, the event data in regards to looking at graphs of how people are using the app itself, or are there any kind of clustering algorithms that you can run to try and look at, maybe there's some kind of topology to how people are using the game and constructing your recommender around that. So those are two kind of intuitions that I would kind of think about. If you're running into a problem with sparse data, or if something fails. So I just wanted to throw that out.
Yeah, so look for other sorts of data is definitely something that I would like to do, but that sort of data just wasn't really available to me from their API. Okay, thank you.
Hi everyone, my name is Helen Lord, and I worked with precision medicine company called Sympatica Medicine to do machine learning for early lupus detection. Autoimmune disease, and that means the patient's own immune system attacks their healthy cells, and I wanted to answer 2 questions. Genes are indicative of whether or not a patient has lupus, and second, can we accurately predict if the patient has lupus? So the data that I was working with was 60,000 features, and each feature was a different gene expression level, and I had 116 patients, 98 positive for lupus and 18 control. So I was working with a baseline accuracy of predicting all positive of 84%. And you can see with this data, one of the big issues that I had was that it was very wide. So I wanted to focus on dimensionality reduction in order to find the features that were important. So this is my pipeline from data prep all the way to final results. I started by reducing my features from 60,000 to 32,000. And I did this by eliminating any gene expression levels that were negligible in both classes. Then I ran those features through random forest and lasso models in order to get my first selection of features, took those sets, ran them through a gradient boosted model to get my final gene identification. I did my model using the metrics of accuracy, precision, recall, and F1 score. The first model that I used, random forest, I did feature importance selection. Every time I ran this model, I got rather inconsistent results, very different features coming out of it. First, random forest selects features independent of their values. And second, the model will cluster features together and select from those clusters. Okay. And this makes sense from a biological standpoint because so many genes interact together to get the same result. Then for lasso, I used aggressive regularization to force low betas to 0. Then I selected those non-zero betas. Consistent way for feature selection because the model will bias towards high feature values. It also independently models the relationship between the feature and the label. So it's just looking at one gene and how does that impact lupus. So I took those two different feature sets and ran them independently through a gradient boosted model. Took the top 25 features from each of those gradient boosted models and compared them to see what genes were coming up as important. And in order to alleviate the issue of inconsistent feature selection, I averaged this over 50 different iterations to see which genes were most common. And of the top 5 genes identified, 4 are involved in the immune system and do have research connecting them back to lupus already. So these are my baseline metrics that I was working against. You can see 84% for accuracy and a recall of 1 because I was predicting all positive for my baseline. You can see an F1 score here of 91%. And so that was what I was really focusing on improving because I wanted to be able to predict positive and negative for lupus both accurately. These are my final results for the random forest and lasso models. You can see that the F1 score has improved, set 96% here. So I was better able to predict if a patient did or did not have lupus. All right, thank you. My name is Helen Lord, and I work in simpatico medicine to do machine learning for early lupus detection.
So I have 2 questions for you. So the first question is, have you thought about any mechanism to reduce the degrees of freedom like PCA? Certain questions like you have such a small number of observations. How do you divide the train test and validation test?
Yeah, so I actually, random forest and lasso were the only 2 that I talked about, but I did use actually SVD and logistic regression as well. Those didn't perform as well, and in particular, SVD was much less interpretable for getting the genes out, so I decided to focus on these 2. And what I ended up doing was, for cross-validation, I used leave one out cross-validation because I had so few data points, and every time I reran the model, I would redo the split, and so that I was getting different results and I wasn't just getting the exact same set.
See, now that you've narrowed it down to a set of genes and information, are there other third-party data sets that you are starting to be able to identify or look at to bring in to start doing another round of distillation of your features?
Yeah, so that would actually be what I would love to do. So I worked with a startup for this, so I got the data directly from them. And given more time, we would have liked to have worked with a cross-validation set. And so if I could continue to work with them, that would be ideal. I mean, in particular, working with so little data and very imbalanced classes in the opposite direction of the actual population, this is something I would really like to delve more into.
So we don't have 84% lupus in society?
No, thankfully not. I think it's about 0.05% in the population. So we're okay. Most people in this room are probably fine.
Is simpatico medicine, are they going to implement with the changes you found because you found there's better accuracy? accuracy?
Well, yeah, so I am exporting the model to them later this week, and hopefully they'll be able to use it for some of their further research. Yeah. Great, thank you.
Hi guys, my name is Arnav Chaudhary and I'm here to talk about this recommender system that I built for a popular game called League of Legends. So for those of you guys that don't know, League of Legends is the most played online PC game with over 100 million plus monthly users. It's produced by a company called Riot Games. The way the game works is like a user enters a game and they can choose one of 135 champions to play as. Games usually go on for 20 to 40 minutes, and I'd say over the lifetime of playing the game for like 4 to 6 years, I've never even gotten to play more than 1/3 of these champions. So introducing new players and new champions will keep them interested in the game much longer. They'll keep them having fun much longer. And there is an inherent business value. The way that Riot Games' business model is structured is that they operate on microtransactions. So this is an example of a champion, and these are customizations that you can get. So if someone really likes a champion, they're going to go and invest money onto the champion and make it look cool. As far as gathering my data goes, Riot has a really robust API. I was able to use that and aggregate summoner ID data and all the champions that they played over the year 2016. I went ahead and ran some SQL queries, and I was able to create a utility matrix which had it had users as rows and all the champions they played as columns. And the values here are the frequency with which they've tried a champion. So as you can see, it's pretty sparse. I mean, most users aren't getting to play every single champion. From this, I went on to implement my own version of collaborative filtering. The first idea I had was user-to-user collaborative filtering. So an example of this is we have Sally as our user of interest. Sally has played a lot of the similar champions that Bob has played. So I'm going to make a recommendation for Sally based on what Bob has done or what she hasn't done. So Sally's most similar neighbor is Bob, and then so on and so forth. So this uses a k-nearest neighbors approach. And I was able to make decent recommendations going on this metric. However, it felt a little naive. I mean, they're interacting with champions, which are items. These champions as having like internal features and stuff like that. So I went on to go and implement a user-to-champion collaborative filtering pipeline. The first step of this is to create a champion-to-champion similarity matrix. Find a user's top champions and which champions are very similar to that. And make a combine this to get a similarity score between a user and every single champion. And then go ahead and recommend the top recommendation. One really interesting thing that I came upon, one of the coolest things of my project, I think, is the game defines champions as being similar just based on how the game operates. If you play a lot, you know what the similarities are. My data was able to define very similar champion clustering, so it pretty much matches. Like this champion Tristana is similar to all of these champions. The game defines the same thing. So in that way, my system was able to kind of learn things about the game without actually ever interacting with anything other than user data. Moving on, I was able to get similarity scores for a user in every single champion and then translate that into making accurate recommendations. Moving on, evaluating recommenders as a system is fairly hard if you're not going out and deploying it. I used a leave one out cross-validation method. So in this process, I would set a user's interaction with the champion to 0 and then attempt to predict that interaction. The error would just be the RMSE between the actual and the predicted. So the baseline was just randomly predicting. I say you can try this out of 135, you can try this out of 135, just randomly predicting champions. The user-to-user collaborative filtering was about 46% better. The user-to-champion collaborative filtering was about 57% better. So my recommendations were pretty good. For future work, I'd love to be able to implement SVD as a form of matrix factorization. A lot of the similarity metrics I was using relied on distance, and distance works better in lower dimensional spaces, so I think this can improve recommendations. I was only able to get an MVP running on a subset of my data, so that means 500 users by champions. So running this on Spark with my 130,000 users would probably improve recommendations. I'd also like to create a web app where I say, where a user can input their username, and I can kind of inform them of what gaming tendencies they have and Arnav, and I built a League of Legends champion recommender system. Questions?
Ask a question. So first, I thank you for doing this, and I'm really excited because I built a whole team around games in my earlier career.
Yeah, I love this.
Yeah, so like you're doing this work. Question for you, right? So we are comparing the performance of your work. Yeah, you're comparing that with random. Have you thought about is that fair, right? Should we compare with something that's like a very simple kind of logic, and you need to show you're stronger than that? For example, the most frequently purchased champion instead of random, right? So have you thought about those kind of logic?
Yeah, that is interesting. So I do like that idea, like saying if I recommend to you the most popular champion, look, actually that's an interesting suggestion.
Yeah, I encourage you to think about that because like if you're not even as strong as that, then you're not good, right?
Yeah. Actually, yeah. I mean, I can go and create that as my baseline and see if the other collaborative filtering methods I have. I'm inclined to think that they would be because I do think that users have like inherent tendencies that is represented by what they have shown interest in.
I think it's like that will make your kind of presentation and project more powerful and persuasive when you compare to that compared to kind of hey let's just compare to random.
Thank you. Cool. Thank you.
Hello everyone, my name is Nick and today I'm going to talk to you about my Capstone project. It is a project with using news article text to determine sentiment analysis and topic extraction. So the motivation behind this was that most people usually have a single news website that they use like Fox News or CNN, and despite those media's best attempts, they are still human and they will still end up having some sort of sentiment leakage in the things that they write. So my goal was to develop a product that would be able to allow users to quickly and easily identify articles of the similar topics, but the opposite sentiment. So some of the project challenges were that I didn't have any data to begin with. In fact, all of it had to be scraped from the web and put into a MongoDB database. So the other issue was that there were no labels to this data. In fact, if you take a look, one single document would look like this: ID, URL, as well as an article with a long string. And then after I got all that data and found a way to deal with it being unlabeled, I then had to classify new data within the bounds of that, the data that I already had. And finally, I had to deal with sentiment classification. So the first thing I did was I went through topic extraction. In order to do this, I did Latent-Dirichlet allocation on the entire corpus of my database. And then each article was then transformed individually to extract the top 3 components based on that LDA model into their own separate bins. I then clustered on those topics. Now this is a little bit different than what most people would do. Rather than clustering on the singular transformed component, I took the top components, the top 3 components, and extracted the top topics based off of those components, and then clustered on those. So as you can see, if I extracted gun control and elections out of Article 1, I would then cluster that into the green box over here, or the economy would go to blue, and so on and so forth for all the topics in my database. And then after that, I would classify their sentiment. So to identify the sentiments in these topics, I extracted the topic first, and then the top featured words of that topic. From those top featured words, I can identify sentences related to that topic, and then classify the sentiment on that. Now, initially, I didn't have a good labeled data set for this. I actually went in and manually labeled roughly about 1,000 sentences from my corpus, either positive or negative. At the moment, with the prepackaged NLTK sentiment analyzer that was trained on Amazon web reviews, product reviews, was predicting positive for every single sentence. So it wasn't exactly applicable or relevant rather to the data that I was using. So ultimately, the full pipeline is going to look somewhat like this. So it would go scrape the data into MongoDB, and then tokenize, lemnitize, and then pass through the vectorizer and LDA model, and then get clustered. New articles would come through the same pipeline, and then get instead returned from the query database a new URL for a topic for each of the 3 topics within each new article that the user would give. My name is Nick, and I did a model on news article sentiment analysis and topic extraction. Thank you. Any questions?
What kind of relationships were you able to see between the topics that you analyzed? So you mentioned control elections, and so were you able to see that users were more likely to click on one topic or more likely to another? And which
yeah, so actually, I incidentally clicked to this page, and it's kind of fortunate. So the latent Dirichlet allocation model was actually, if you look at the components themselves, I had a vocabulary somewhere in upwards of a couple 100,000 coming out of the TF-IDF vectorizer. And so basically each component was relatively uninterpretable on its own coming out of just out of the LDA model. But once you passed in an individual article, you started getting something like this. So this topic right here came from one of the articles in my database, and you can see like it was popping out top words like committee, hack, leak, email, Putin, Moscow, and this would be very. This actually was related to the Hillary Clinton email scandal, and I believe it was one of the articles talking about how they were talking about Russians potentially having hacked your servers and actually been able to leak them. And then there was another one. This was a bit more obvious, but it was about the 2016 elections and how like they were like, you know, it mentioned Clinton, Trump elections clearly, and House Party, a whole bunch of words related to the elections specifically. I hope that. Yeah.
I'm just curious, when you hand labeled your data and then trained your sentiment classifier, what were some of the metrics that you kind of observed?
I'm sorry, some of the metrics, meaning like top words that would have been applicable to.
So
negative.
I was just curious. I was wondering if I could get a little bit more information on how you trained like what you used to train your sentiment classifier, if NLTK.
Sure. So I did something very similar. So the pipeline is actually. So essentially, the sentiment classifier would sit underneath like basically it was the last thing that happened in the pipeline. In order to train it, I ended up doing cross-validation search on a couple different models, and ultimately settled on a multinomial naive Bayes model as the predictor. With that being said, I think a lot of the features that were ultimately passed in, so each time the model had to predict, it was predicting on just a single sentence. So a lot of the extraction actually came from extracting through the latent Dirichlet model and then into the clustered topics. And by doing that, I would say I almost saved the sentiment classifier having to classify on things that weren't pertinent. So everything that I would pass it was related to the topic rather than just passing a whole article and saying, look at this and tell me what the topic happens to be sentiment related. Because you could potentially have an article that's got positive for Trump, negative for gun control, and positive for abortion, or some other random version of those ideas.
Cool. I mean, I think it's an ambitious project overall, having to go get the data, then deal with the data, then actually start doing analysis. So, yeah, congrats and acknowledged. One thing is you think about how to kind of present and continue to progress this is you might use something that's known in the world to compare against. Examples might be red feed, blue feed, because there's a lot of information out there, and comparing how your topic clustering shows similar or differences to that and why that might be the next question. Sure.
Yeah, I appreciate the feedback. In fact, I did have previously a results slide, but the model was taking a little bit of time to train, so I wasn't able to get anything safer out of 50 data points, and they were rules out of 50 data points. Thank you.
Hello everyone, my name is Juan Salas. My project is resonating with you. So the goal of my project was trying to answer this question. So as a content creator, as a content user, is there a way for me to find out if there's any correlation between the demographics or certain target audiences and the type of content I create? And is this information useful for me to target different audiences more effectively? So in order to answer this question, I collected data from multiple data sources. So this is an original data set that I scraped. I took 250,000 Tinder profiles. I chose Tinder because in there you find demographic data of the user. You have their age, their schools, their jobs, but also you have the song to which they identify with the most. There you have a favorite track, and that isn't necessarily taste, but identification. So I aggregated that data with Spotify audio features about those tracks, Instagram data about how many media they share, data from the 2017 university ranking to have tuition costs, so it would give me a sense of purchasing power. And University of Cambridge has a Myers-Briggs classifier, so I also use all this data to perform these inferences. So in order to find out how this population looks like, we see that they're mostly millennials in their early 20s, and they're distributed across 9 US cities that I chose for them being the most populated. So this is what the tuition costs look like for different cities. We see that, for example, there's New York and San Francisco are more densely populated with the higher quantiles of tuition costs, while Phoenix and Chicago are mostly with the lower quantiles. It's kind of interesting. And there. So for the psychological profile, I chose the Myers-Briggs type indicator. So it's based on 4 economies of attitude, information gathering, decision making, and structural orientation. This is how they are distributed across the data set. It's interesting to see that regardless of extroversion or introversion, you have the sensing type is underrepresented. This is not typical, so it's kind of particular population. And I think it's because the sensing type values information gathered by their senses more than what they read. And so therefore they don't consider this information relevant either about others or about themselves, so they don't state it. All of these indicators are what the users actually state about themselves. So it's not inferred, it's just label data. So as for the tracks themselves, I clustered them into 3 different groups. The 3 groups are the hits. They are mostly trendy. They tend to have explicit lyrics. You have high energy tracks. They have higher volumes, more positive lyrics, major scales. And the third cluster, the deep notes, are mostly instrumental, more, they're not as loud. They're you see, for example, examples, explicit hits are mostly hip hop artists. High energy tracks are more rock and roll artists, and you have Pink Floyd, Glass Animals. So that's kind of 3 different distinct types of content. So how can we put all of this together? Basically, let's say we have a product, like in this case an iPhone X pre-order, and it's a luxury item. So we will try to target high purchasing power. It's a higher tuition cost. There's people that value appearance. So let's say we target the people with high attractiveness, which is a score that Tinder gives about the users. So it's a product that's consumed alone, so let's target introverts. And it's a planned decision purchase, it's a pre-order, so let's target judging and rational people. So if we create a campaign specific for this demographic profile, which songs should we use? And we see from this data set that these people prefer songs with the second cluster, the high energy tracks. So in theory, what we would find is that these people might identify better with these tracks. So therefore, with this, our brand will resonate better with them. So some privacy concerns about the data. I was able to scrap all of this data on my own. It wasn't trivial, but the data is readily available. I think that some of this data is actually not useful for the actual users, like the attractiveness score or the distance being most notable, because distance allows me to triangulate a user-specific location. So if I materialize my bots in 3 different locations, I can triangulate their position. And it's not relevant information for the actual user. Some future steps, I plan to get more and better features, more data and better features. One of the things that I want to work on is actually extracting features from the profile images, trying to determine the people's race, if they're outdoorsy, if they do sports, and identify influencers, and doing more precise marketing segmentation based on consumer habits like recently. Thank you. My name is Gonzalez, and this was my project, Resonating Millennials.
So question for you is, I think in the payments result slide, it looks like the 3 groups are almost perfectly, divided. So I would imagine you only use 2 dimensions to run the payments on, right? Yeah.
You mean
is that true? Yeah, this is the graph I'm referring to. So is that true? You only use 2 dimensions, and if so, why? If not, what did you use?
Oh no, sorry. This is the 2 principal components. They explain 30% of
okay, so PC1 and PC2, right?
Yeah.
Okay.
So the features that I actually use includes the loudness of the song, duration, danceability, genre. So popularity of the artist, popularity of the track. All of those are provided by Spotify. In my future work, I try to work with the actual audio samples.
Okay. A quick follow-up and ask you, why do you choose to run the payments on, against a PC1 and PC2 instead of, let's say, putting 7 kind of continuous variables, right, and run the payments on them?
Oh, I use PC1 and PC2 just to give a sense of how the clusters were represented. So for the actual clustering, I'll use all the features, and they're mostly continuous values between 0 and 1.
Correct. But if you run the clusters on, let's say, 7 kind of variables, it's not going to look like this clean, right? Or is that it actually look this clean?
No, there is some overlapping, but
so indeed you plug it by PC1, PC2, you look like this.
Yeah, so PC1 and PC2 do have a really small overlapping, but they're fairly distinct. So yeah, it's just for to get a sense of the data.
So you looked at a bunch of sources of data from your first slide, and did you find that, if you had to drop some of those sources of data, or which are the most valuable, like which ones do you think are the most valuable? Do you think out of the sources of data, kind of population that you're?
Yeah, so definitely this population is biased. First, because it's mostly millennials, and second, because they're presenting a version of themselves that's probably not who they actually are. So,
and I'm not sure how, maybe like Tinder only caters to a certain type of millennial as well.
Yeah, definitely they're single, but this is the, or mostly single. So there are patterns that they all share. This is specific audience. The thing that I thought it was valuable, this data set, when I first started the project, I didn't know if there was any signal here. I thought that it was interesting enough to pursue, because you have demographic data, you have data about their behavior, about their preferences, and there's data that you can align with actual customer segmentation, like their universities or their jobs. I can align that with a cluster or the 2017 university ranking and see what their tuition is, how their average income is looking So mixing all of these, there's a lot of information to get about those users. This is marketing all. So that's why even if the population is skewed, I thought it was valuable enough to pursue.
Just a quick question. What were some of the keys that you used to join these data sets together?
Yeah, so for I first started by scraping the Tinder profiles. That alone was a challenge. I got a fairly automated pipeline. I scraped 70,000 registers that took me 2 weeks. Getting 200,000 records took me 5 days, and I expect to be on the 500,000 by the weekend. From there, you have the Spotify tracks that they have stated that as their relevant tracks to identify themselves. It's called Spotify theme track. Go to Spotify and query about those specific tracks, get the audio features and metadata, and then from their profile, I see they have stated a university they attended. I get from data.org, from the 2017 university ranking, I get the university ranking, tuition costs. My bots, I use 20 bots across 10 different cities. A female bot across in each city, where they are located. And as for Instagram, the ones that haven't created their Instagram, I have get the username. So from there, I can get their media accounts, how many media they share, some sample images, and I'm trying to get how many people are following them in order to identify influencers.
Yeah, I'm wondering how you got to the Myers-Briggs component.
Oh, that's actually what people state in their bio. So just regular expression. I tried to use the magic sauce algorithm from the Cambridge University, but it doesn't really perform that well because bios are short sometimes, so it's not really accurate. But now I have labeled data at least, so if I get more data, some classes are underrepresented, the sensing type especially. So by gathering more data or performing more inference, I can probably build more sophisticated models to predict that. Or straight away, or increase them and use a different kind of segmentation.
Not necessarily a question, but a compliment. I think a lot of people don't think about privacy and what should we be looking at that maybe that doesn't matter. And so I think in your conversation and pitch, the fact that you've noted things that are not valuable and therefore also somewhat privacy invasive is a great aspect. So keep that in whatever you're talking about. Nice job.
Yeah, thank you. I was pretty concerned about this point. I actually discussed this with my tutors. Should I move on with this project? Should I focus on data privacy? What should I do? Because I thought it was a serious aspect. There's people that might exploit you, for example, for scams, for blackmailing, whatever. There's lots of things that I think are actually not needed by the users. Once you have configured your distance filter, you say that you're interested in matching with people that's 5 miles from you. You don't really care if they're 3.1 mile away from you or 3.2. But someone's trying the position, they will care. They actually will exploit that information to know where you live, where you work. Say you connect at 10 p.m. And the fact that you can actually track users, specific users across time, that's pretty sensitive too. So I think that's a discussion worth having.
My name is Navita, and my project is about inference sentiment from financial headlines. So the motivation for this project is coming from the increasing influence of news, blogs, and sentiment in social media information on the financial investing community. Sentiment analysis allows investors and portfolio managers to factor in news sentiment data into their analysis. So the goal of my project is to identify sentiment polarity as positive with 1, negative, neutral, and predict sentiment scores. So the training data is from a research paper, this annotated headlines dataset, and the test data is for the current headlines from an API. So the two base models I used for this is the lexicon-based approach, which came up with the accuracy of 0.54%, and the identity sentiment analyzer, and the accuracy was 63%. So for my model, this is an NLP pipeline I used. After exploring different options, I used POS tagging and monetizing for tokenization and bigrams and TF-IDF for vectorization. So for my models, I experimented with 3 different models: random forest, multinomial, naive Bayes, and logistic regression with SGB optimizer. And the graph on the left side shows the F1 score. As we can see, the multinomial and logistic perform fairly well and close to the performance actually matches. But the interpretation I got from logistic regression was much better. And the graph on the right shows the precision and recall for each of those models. So I put that here just to show that the precision was high for all the models, but the recall was very low. So the problem, in my case, recall means not able to predict the negative sentiment in a headline, which is also very important. So how do I address this problem of low recall? Unfortunately, I don't have more training data to add to it, but I do have more large amount of unlabeled data. So is there a way I can make use of that unlabeled data? So that's when I tried precision bootstrapping. So this is like a semi-supervised self-training method, which is aimed to improve the performance of the supervised model by learning on both labeled as well as unlabeled data. So this diagram shows the high-level overview of the method. So we start off with the labeled data. After holding out some data for validation, you train the model on the rest and use the trained model to predict the labels on the unlabeled data, and then expand your training data set by the ones that you just predicted to the original labeled data. And then you retrain your classifier on the new expanded training data set. And you do this in iterations, and the main key thing is at the end of each iteration, you evaluate on the original held out labels, and whenever, for each iteration, you actually predict labels on a new set of unlabeled data. So this is the F1 score, how it progressed over different iterations. So with the data I have, unlabeled data that I have, I did 5 iterations of this. And the model, the F1 score that is reported here is the F1 on the held out labels. So the model, I chose the model from the iteration 4 because that gave the right balance of precision and recall that I'm looking for my current problem. So this is the result of the precision bootstrapping, the F1 score before and after. So as you can see that the F1 improved by 9%, and I had to trade off the precision by only 2%, and was able to improve the recall by 16%. This is some of the future work I'm planning to do on this, which is an extension to this. And again, my name is Navata, and my project is about financial headline sentiment analysis. Thank you.
Last question. So maybe I missed this, but like, what's the dependent variable you're predicting this analysis? Sorry, what's the dependent variable? What's the target variable that you're predicting in this analysis? Because you show the recall and precision. What exactly are you predicting? Maybe I missed this.
Predicting the sentiment in a financial headline.
Is that a continuous? Is that
It's a classification category, but like positive.
Okay. So for every kind of that piece of data, you have a binary say is it positive or negative?
Yeah, positive, negative, neutral.
Neutral. So you have so it's categorical.
3, yeah.
Okay. Yeah, I think I'm still a little bit confused. If your dependent variable is like categorical, right? 3 possible outcomes. How do you kind of measure the model performance? Because for binary, it's easy to measure, right? But you have like 3 possible values.
Yeah, I have 3 classes. So I'm using the F1 score is a average of all the 3.
So if you were to look at kind of regression 3, 4, and 5, which 4 is your curve line out, of course, is there other types of areas that you might explore around how you're doing classification versus just sentiment analysis? Did you play with any other ways to do classification besides positive? of the financial results.
For my problem,
For your, because the idea is about a hedge fund, and I'm looking for positive or negative.
Yeah.
Let's go to a business problem. Is there another, do you have any other ideas of where you might distill information from that headline, besides just sentiment? I guess what would be a different axis you might look at?
probably like the actual numbers, like the quarterly financial statement, or like actual numbers that they report, like how much they missed the quarterly projections or how much they gained. So yeah, that would be another thing that we can use.
So yeah, just starting to think about other types of data that you might pull in to solve the same business problem. It's great that you got the boost in terms of kind of precision in F1, but you know, how do you go to the next, we call it F1, how do you go to that next level of how do we then use it?
Yeah.
Awesome.
Thank you.
I feel really lucky because I got to work on this amazing project that's really dear to me, and I got to get feedback from all these really great people, wonderful group, and a lot of motivation from them. So my name's Mike Malatesta, and I'm a golfer. And just a quick show of hands, everybody golfer. Good. So if you're a golfer, you probably have asked yourselves something similar to these questions. Will there be a lot of people at the golf course tomorrow? Should I play golf tomorrow? In order to answer these questions, I partnered up with my local golf course. And in order to give players an idea of whether or not they should go, I predicted the crowd level at the course. But that's not the only thing that goes into whether or not a day is good for golf. The weather is also important too. So I integrated that. So here I have the crowd level plotted in the top panel for every day since 2011. And in the bottom, I have the trend component of the seasonal decomposition of the top panel. And it shows that the course is in decline since about 2013. So what I wanted to do to combat that decline was give the course director a prediction of the crowd level in the near future so that he could have a better idea of when to offer promotions, whether it's on the course or in the clubhouse. And then for the golfer, I wanted to give them a sense of golfability. I call it a golfability score. And the predicted crowd level goes into that along with weather conditions. So the methodology for my modeling was that I integrated weather data that I scraped from Weather Underground with the course data that I got. I did some feature engineering and then used a random forest regressor, trained random forest regressor for my predictions. I use a random forest because it's able to account for the interaction effects between the weather features without actually explicitly engineering. Some of the features that I engineered included cumulative precipitation, which is just the precipitation from the day before rolled in to get it. Because I thought that water on the course from the day before would have an effect on crowd level. And then because the data is inherently time dependent, I gave the model a sense of the seasonality by engineering a month, year, and day of year feature. And then to give it a sense for the weekly variation. These are the most important features from the random forest, namely day of week. So there's a really large variation throughout the week. So the performance of my model compared to a mean prediction baseline, just constant, and a seasonal prediction, just modeling that seasonal variation and using that, I got a lot better. 25 compared to 40 initially. The data is pretty noisy, so this is actually very good. So the thing that I'm most proud about is my web application. I used Flask to fetch the 10-day weather forecast and use that as input for my trained random forest. in order to predict the crowd level for the next 10 days. And then I took both the 10-day forecast and the predicted crowd and put it into a golfability function that I created and output that as well. And that's deployed on Elastic Beanstalk. Here's a sample output of my application. Here I have the predicted rounds, which the course director could go and look at this and plan promotion for the next 10 days. And the golfer could come on here, and because a floating point golfability score I didn't think was very user-friendly, I pinned it into perfect, great, good, and bad days. Don't go golfing tomorrow. A little bit more about the golfability score. I averaged the days that the golf director described as perfect weather in the data. He actually kept notes for every day. To get these values for my perfect weather, and I took the difference of the forecast to that as one of the terms in my golfability score. And then other terms are the precipitation, which lowers golfability exponentially, and crowd, which also lowers golfability. My name is Mike Malatesta, and I built a crowd predictor for the Diablo Country Club.
Were you able to compare your prediction of crowds to Google Maps' prediction of what?
That was mentioned to me. So no, I did not compare that. Fantastic idea.
Motivations of the golfer picking a day and the course owner diverge.
Say that one more time, please.
So if I'm using this as a course director, I want to probably smooth some of my usage, get people out there on a bad day. Is that divergent or convergent with the golfer's desires? And how would you solve that from a business perspective?
So the course director wants more people out there when it's not crowded, but the golfer wants to be there when it's not be crowded. So I have to do some testing, possibly, and see if this actually can affect whether or not people go out, and if influencing people to go crowded on the day when it's not crowded. I think I'd have bigger problems if I got to that point.
Stay on the real world, and somewhere in there there's some value.
It looks like you're trying to put in the day and the weekday, how you imagine those are strong variables, and the year. Question like, how many years of data do you have, and how do you try to like yearly now?
So it's 6 years of data since 2011 until a couple months ago. How I account for the changing seasons is not exactly clear. I mean, the model gets what year it is. So right now it's saying it's 2017. I'm going to treat this data like it's 2017. I don't know exactly how, with the fact that we had kind of variable weather recently, a possible explanation for the decline in the course is that we've had really bad winters. Show you that plot again. There it is. So if you see here in the winter, it's a pretty sharp decline. These are when we were in drought. And then the last two, the winters are a lot shallower. I would say that it's not handling that very well, but it is capturing the seasonal effect because it's doing better than just a seasonal model. It's capturing that, and it's also capturing the weekly variations, as well as precipitation was one of the most important ones. That's why I separately included that as a different term in my golfability, because most of the time precipitation is zero. When you have a lot of precipitation, people really don't like to go. Thank you. Did that answer your question?
Just a quick question, if you tried any other repressors, there were any
Yes.
differences that you noticed?
Yeah, I did try adaptive boosting, but to perform as well. Another one, Cat Boost, I'm sure you're familiar with that. Performed pretty similarly, took like 13 times as long. Originally, I was training in line on my application, so that would work, but now it's models different. Anything else? Cool.
Hi everyone, my name is Eugene and I'm presenting you my project, the Visual Reasoning AI. Motivation for this project was the fact that neural networks are pretty good at recognizing objects. They can really distinguish cats from dogs, but what we really want them to do is to be able to reason and understand visual information. Are there more balls than green things? To answer to this question, you really need to know a lot. You need to understand colors, shape, be able to count and compare. And I was building a model that is able to do it. I was using this data set, which consists of 100,000 images like this, where each image has 10 questions to it, and object exists in 6 possible colors, 4 possible shapes, and 2 materials. I was inspired by this paper that got recently state-of-the-art results for this data set and introduced a very general model for this type of problems. So I built my model in Python using PyTorch framework. On a high level, my model looks like this. It consists of 2 neural networks, where one neural network is working with question and second is working with image. And image features are being influenced by information from the question to get correct answer. And I was mainly experimenting with this part where I was trying to use different number of condition blocks, and this part where I was trying to use different image extractors to get more relevant features for this model. And when I built this model and it was challenged myself, it turned out that the model needs around 72 hours to converge. And it was a bit of a problem for my Turing project. So to overcome this, I used a large machine with multiple GPUs. I parallelized training of my models and used variable learning rates. So in the end, I was able to train several models at a time and get the speed up for a single model up to 50%. Here are some of my results. And it turned out that the model was pretty robust to the changes that I was doing, and a lot of my models landed up between 96 and 97% accuracy. And at this point, I started to play with my models, and it was really enjoyable to ask questions and got answers. So I decided to build a web application where you can ask your own question to my model, and it's available on this URL, visuallyreasoningai.com. And what is cool about this application is that nevertheless, the model was trained for several days and pretty complex. It is doing its answers pretty fast, and you can play with it in real time. And finally, I want to show how my model is doing it. Here is the picture and question from which I started my presentation. I input this information into my model, and I took a final convolutional layer of my network. I averaged out all the activations to get one feature map and put it on top of the original picture, and this is what I got. So you can see that the model was able to identify the most important areas of the picture for answering this specific question. And if I will ask different questions, what is the color of the object that's closest to the blue pulse? Look what will happen. It switched its attention to exactly the area that's important for this question and answers correct. And I think that it is amazing. And my project usually with AI. Thank you. Questions?
Where were you getting the most noise as you were running the early iterations of visual results? Because clearly that's very complicated to try to distill 2 or 3 axes, where was it getting most confused, I guess, in the training set?
I think it's,
In terms, as you were looking at early results, I imagine you had to start retraining some data, or did you not have to retrain any data?
yes, yes.
Where did it get most confused, and where did you have to help fix the training set?
Basically, because I was generally trying to reproduce the original model, so problems were basically in some debugging. So when I finally managed to build the original architecture from the paper, so it all started training good.
Just a quick question about your data. I'm just a little. I want to understand a little bit more about your target variable and what you're using to train to backpropagate information across that.
Sure. Yes. In this data set, there were only 32 possible answers, like it's all the possible colors, shapes, yes, no, and counts of the objects. So like this was classifier of the 32 possible outputs. And when I was training the model, it was in 2 directions. So backpropagation was this way, and this input like was backpropagated to this neural network as well.
Thanks.
Just kind of basic, how were you able to link kind of a question that you asked to the image itself?
Oh yeah, sure. In the data set, each image had 10 questions, and like it was a metadata, so each question had an index of the image and the correct answer for it. So like each data point that they had is an image with its index and question and answer.
Oh, I see. And were there ways that you could trick your algorithm based on the question you were asking?
Trick? Yes, I can show you some. Some problems here. So basically, lots of these questions that was in this data set, they were pretty complex and like they were multi-layered. And so in this way, model like more biased to complex questions, and it's biased to answers like with not large numbers. This is a nice example. So when I ask how many objects are there, it's answering wrong, and it's answering wrong. But at the same time, if I'm asking about smaller number, how many cubes, how many cylinders, answers are correct. And occlusion is a problem as well. So when this object is partially occluded, it has problems to answer it, and there is as well some bias to answer it more often. When you're asking about count, model is used to answer like more than 0. So yeah, so you can see I'm asking how many yellow cylinders. It is asking how many yellow cylinders. How many yellow spheres one, and how many yellow cylinders one as well. Like it is ambiguous situation, and model like trying to answer yes more often than not.
All right, folks, we're going to take a quick intermission, about 5 minutes. So come get up and circulate your blood a little bit, and then we'll see you back in 5. Alright, folks. We're gonna have you sit down. We're gonna get started on the second half of the program. You have to introduce your thoughts. So our minutes. We just have to so loudly. Okay, folks, let's go ahead and get seated. We'll begin the second half of these presentations shortly. All right, folks, welcome back. I'm excited to get the second half of this program off to a good start. And let me introduce Ms. Selena Chen.
Hi everyone, my name is Selena Chen and I developed a wine recommender for my Capstone project. When looking for a new wine, I'm often overwhelmed by the selection out there and sometimes disappointed by the recommendations that I get from waiters. So I thought, how can I get some recommendations from experts? I used data from Wine Enthusiast magazine where they had over 100,000 unique wines and expert reviews. These experts are trained to distinguish and elaborate on different wines and distinguish between them. Here's an example of the Napa Valley Cabernet, which is described with flavors like layers of chocolate and graham cracker, or dappled in vanilla and jam, which sound just delicious to me. So using these wine reviews, I use an NLP approach in order to tokenize the words, use pattern speech tagging to pull out nouns and adjectives that I want to use. I lematize and then remove common wine stop words like varietals. And then I use this and put it through a TF-IDF vectorizer in order to get a document feature matrix to establish the important features of these wines. Here's an example of different features comparing a red and a white. As you can see, the terms used to describe a robust Cabernet are terms like thick, tobacco, and layered, while terms used to describe a sweet Riesling are blossom, grapefruit, and elegant. Using this TF-IDF matrix, I drew cosine similarities to make recommendations. Looking back at that B-side Cabernet, recommendations that come out are other Napa Valley cabs or a Tuscan red blend, which have similar tastes in it. In order to be able to use these recommendations, I developed a product called WineStab, which is a web app developed on Flask and Heroku. With this app, users can get recommendations two ways. Bottle and selecting from a random sample from my library, actually enter text into the describe by taste field and get recommendations that way. And at the bottom of the page, the top 5 recommendations will be generated. Ideally, a user will enter in more detailed descriptions so that they can get better recommendations. Now, validation for recommenders can often be kind of tricky. Aren't able to taste these wines. So, one way I chose to validate was to simulate a situation where a particular bottle of wine was shown to a user, and then similar wines were. One comes from my wine style recommender, comes from another credible wine website. In the survey, I asked the respondent to just choose which one they thought was the best recommendation. This bar chart is the results from that survey, the wine, and the dark red bars, the user chose the wine style recommendation. And the other gray area, they chose the other one. 63% of the time, people chose the wine style recommendation. steps I'd like to take, one of the main things I'd like to do would be to acquire inventory information so that I can make some more actionable information. My name is Selena Chen. I developed wine style.
Quick question. Just wondering why you chose cosine similarity over similarity measures.
Well, I was dealing with text, so I wanted to make sure to see the way that lines were similar to each other. So basically, each line has its own vector, and I wanted to make sure it's just perfect.
Within your website, did you control for where you listed the wine style recommendation in the first, second, or third slot in terms of randomizing it?
At the bottom of the page?
Yeah, well, as you were presenting the different selections, did you always list the wine style in the same spot, or did you randomize the order of the?
Oh, no, in the survey it was random. Thank you.
Hi, I'm Eric, and I'll be presenting to you the beer project. So even though there are only 3 basic ingredients that go inside all beers, hops, barley, and yeast, there are over 100 distinct styles with distinct tastes. And from the light lager to the universally loved IPA, these different styles are received very differently by the beer community. So my project revolves around trying to find exactly what are the tastes that are the most impactful towards how a beer is perceived. And I do this by finding the top tokens for every style of beer. So just to illustrate the point, if I have 2 different reviews for the same beer, but with different scores, I want to be able to quantify exactly how much do almond, malt, and pine taste impact the score of the beer. And I do this by taking 1.5 million data points or reviews from Beer Advocate, separating them into 2 different categories of reviews, amazing and not amazing, where amazing is a perfect 5 of 5 score in taste, and building a classifier that takes the review text and classifies whether or not the review thinks the beer is amazing. Since my features are coming from the text data itself, I need to use a standard NLP processing pipeline that involves parsing, tokenization, filtering, vectorizing, and vectorizing. I just want to point out that during the filtering step, I had to use an expanded set of stop words, because unfortunately there were a lot of words that had very strong predictive power in my classifier, words like growler or carbonation, which makes sense because who wants to drink a flat beer served in a plastic bottle? But they had very little overall usage for the overall goal of my project. So finally, I was able to feed these TF-IDF vectorized reviews into a simple Gaussian naive Bayes model, which allowed me to interpret the tokens as this useful TF-IDF weighted likelihood that a beer is amazing. So when I ran this model over the IPA styles of beers, the results turned out to be pretty good. It managed to successfully find out that hops, malt, citrus, and orange are important tastes for IPAs, which you would expect. But there are issues with the Gaussian naive Bayes model. The first one is that Gaussian naive Bayes assumes that the TF-IDF features that I use follow a normal distribution. That might be true if I'm looking at extremely common English words over large documents, but that's simply not the case. The other issue is interpretability. Gaussian naive Bayes is very interpretable, but what does it mean to have a TF-IDF weighted likelihood that a beer is classified as amazing? It would be much better to be able to say instead, what is the likelihood that a beer is amazing given it is malty? Or what's the likelihood that a beer is amazing in flavors? The Gaussian naive Bayes model with a Bernoulli naive Bayes classifier. And when I run the Bernoulli naive Bayes classifier over the same IPA dataset, I get similar top tokens, but it also has the double added benefit of scoring higher on accuracy and recall compared to my old model. When I ran the Bernoulli naive Bayes model over the rest of my non-IPA beers, they successfully found what the top tokens are for all the other styles of beers. And just to go through some of them here, for example, it managed to find that chocolate and coffee are important tastes in imperial stout, which you would expect. I also found pumpkin and spice are important tastes in pumpkin ale. I just also want to point out, I'm not making any judgments here, but according to my classifier,
people who like light lagers also like the taste of water. You can determine that however you want, but I'm not gonna say anything. Unfortunately, I can't go through all of my results here, but if you're interested, please feel free to contact me. Thank you. Any questions?
Yeah, I think a lot of interesting findings. What do you think is the potential application for the findings?
Right, so when I framed this project, I kind of framed it as a personal interest point of view, but I think this could still be useful for beer makers, because beer makers are able to tailor exactly what needs to go into that beer. So actually, if I go back to this slide earlier, you can see pretty consistently, even for the light lagers, that malt is a very important feature for beer. So let's say if I was a beer maker, which I'm not, I'm just an enthusiast, I would probably double, if I had this information, I would double down my efforts to make sure that my beers are extremely malty.
Thank you. I think maybe you can combine that with the previous presenter, right? So to figure out the alcohol kind of physics rather than.
Thank you.
All right, so my name is Alan, and my project would recommend the best college for you. So the problem is when colleges advertise themselves, they often show what the best they have is to offer, but often neglect to advertise students factors such as student debt or dropout rates. So what I did is to create a Flask application where students can first enter their background information in terms of ethnicity, family income dependence, and if they're first generation student or not. And then secondly, enter what is most important to them in terms of earnings, debt, loans, and completion. The data set I used for my project was the college scoreboard data, which had over 7,000 schools and 1,700 features. The main problem I encountered during my project was that over half of these schools had missing values in important columns such as earnings, debt, loan, or completion. In order to address this, I fit a random forest regressor to predict these null values and retain up to 5,000 schools. So as you can see, my method was a lot better than the standard method of computing nulls with simply the median. So in order to incorporate ranking into my project, I did a percentage cutoff approach where, for example, if I rank completion as my least important feature, I'll take my entire data set, sort it by completion, and take the top 70% of that, pass it to the next iteration. The next iteration, I will do the same exact thing, the second least important feature, and cut off 50% of that data set. And I would iteratively repeat this process until about 0.1% of my entire data set left. By doing this, I can have the first two features have a significantly stronger impact in recommending than the last two features. So some interesting things I found throughout my project was if you rank based off earnings, you most likely will get private schools and Ivy Leagues at the top, while if you rank most on completion and low debt, you will receive public colleges. So if I have more time, I would love to include more features for users to specify in terms of curriculum specification, school size, and school activities. I'd also like to include GPA test scores to better recommend schools closer to a student's range. My name is Alan Liu, and I did a project on college recommenders.
My question is like, how do you think about validating? Is this useful? Kind of, I think it's tough, but have you thought about that?
Yeah, that validation is definitely very hard because most people only go to school once, so they can't really rank different schools. But the approach I did was mostly intuition. As you can see, intuitively, I want the first two features I feel most important to cut off a lot more data than the last two. So it's mostly intuition for now until I get more students, and they can probably give me how they rank
suggestions.
How did you rank feature importance again?
So I would have students rank 4 features, which was completion, debt, loan percentage, and earnings. And originally I have the entire data set, right? And then based off the least important feature, I would rank my original data set based off that, take the top 70% of it based off the sorted least important feature. And then I repeat this process until I have the most important feature left. So it iteratively cut down until this is the most important feature, second most. And this is the size of the data.
It seems like the reason you have to go iterative is because you ended up with too many results
Yeah.
for a single user. Are there other factors you thought might be worth adding in terms of characteristics that a student may want or about the school that are pretty easy to get?
Yeah, there's definitely like a lot of data, as I mentioned, my future work, such as size of college, activities it offers, if it's public or private, but unfortunately I didn't have enough time to add that many specifications into it.
I'm Lee. It's a gorgeous day here in San Francisco, and we are trapped in the basement. So, San Francisco it's a good city it's great for biking, and it's also great for crashing. Last year, according to the statewide integrated traffic record system, there were over 600 bike collisions. That's like two a day, which is what that looked like. So we've got that big, scary right over the Market Street area. But what does that tell us? Is that actually because it's actually more risky? Is it because there are just a lot of bikes running through that area? So bike collision data is generally a bit easier to get, so the statewide system. But bike volume data, that's a bit harder to get. So I figured maybe I could get a traditional way, which is to stand at an intersection and count how many bicycles go by. But there were some scaling issues. Thankfully, there is Strava, which is basically like Facebook for athletes. So this was through the Strava API. Each one of these blue dots is where Strava users have recorded hundreds of thousands of rides. So I divided this into grid squares so that I could then match collisions with the underlying bike volume in those areas. So looking at bike volume, so here was where we had that big, scary red, but we actually see that there was actually a fair amount of bikes going through there. So if combining collisions with volume, we then see that actually the market area, and then greenish, orangish, it's not so bad. Actually, more down around South Mission area, which isn't so good. Actually about 1 collision in 50 strong rides. So the city of San Francisco is actually doing some safety for that here, but maybe here's somewhere where they can looking at that a little bit more closely. A little bit tricky though. There's some limitations in the Strava data. It would be interesting to take a closer look through Strava Metro, which is Strava's commercial data set. I'm saving it $50,000, and I'll get back to you. So I'm Lee, and I would stake my life on riding a bike in San Francisco. Thank you.
What was the kind of granularity that you looked at the bike volume, and was it looking into the squares? Is it time of day or just total year?
So unfortunately, it's not possible to go that granular, at least with the free level of access to Strava. So each one of those points, it has the number of rides that have been performed on that route through the lifetime of that route. So a route may have been around since say 2010 or 2011. So So I did have to do some adjustment to make that line up with the year like that. And in terms of density, there were about 10 Strava routes per square mile. So I didn't want to go any wider than that because then I started having maybe only one or two routes within an area. And I felt that wasn't really representative of the true volume.
Let me ask you, like, what conclusion do you draw out of the graphs, right? It looks like, yeah, interesting graph, you have like 2 dimensions, you have like, both look at the accident rate and also look at the passenger traffic. Any conclusion that you draw? Like business conclusion that you draw? Any insight that you get from that?
I think that would, like what I was saying earlier, that maybe the city might look into more targeted, maybe more around the South Beach area. And it might be, like user-based insurance has been becoming a bit more mainstream. Autos, the personal auto. We don't quite have access to analog for bikes, but maybe something like a commercial biking application might be for bike couriers, for example. That might be something with affordable devices that maybe could be used to price a bit more accurately.
Other than the fact that the red zone is my commute, the concept of kind of bringing that to the city, did you have any opportunity to look at improvements that have been made over the last 4 or 5 years from Spur or some of the other areas where they are actually bike commutes?
I didn't get a chance to look at that. And I think, again, kind of going back to the fact that Strava does collect rider data. Like, I mean, they do have data that's like daily or by hour, the exact time of the day. But what I have access to through the API is only lifetime information. So, in order to get more fine data, I would need to get individual user data, and for that I would have to get authorization engine.
Certainly, I think somebody like Spur or somebody else might be able to help you get access to deeper level, time being probably one of the most important.
Thanks.
Hi, my name is Brendan, and my project is recommending investors to startup companies. I worked on a database provided by Crunchbase, and I found that there's over 15,000 investors, 400 of which have over 50 investments. This means it's not feasible for a startup company to speak with every investor. It's even less feasible for them to find the optimal investor that is likely to be interested in investing in them. The aim of my project then was to make better recommendations and hopefully streamline the fundraising process. I began my project with some broad exploratory data analysis. After analyzing the data, I thought that using a network graph would be very interesting to find insights in the data. I plotted startup companies as investors and investors as nodes on the network graph, with connections between the nodes as investments made. I started looking at some centrality measures. I used a combination of eigenvector scores, which is a proxy for how good your network is, and closeness centrality, which is a proxy for your access to information. I found the combination of these two metrics was very strongly correlated with the percentage of investors' investments that went on to receive multiple rounds of financing. How I'm interpreting this signal is that there is some pattern in the way investment data is being made, strongly based on the relationships of those investors. I was trying to figure out how to commercialize this insight when I decided to build a recommender model that would recommend to startups investors that are interested in investing in their company based on their current investors, with the insight that investors tend to co-invest frequently together. I validated this assumption by speaking with many VCs who confirmed that follow the leader is a very popular investment style where people base their investment decision based on who else is currently invested. My model had a recall score of 13%, which is a 60% improvement on the baseline. The baseline here is just recommending the biggest investors. Recall here is my model's ability to accurately predict investor-company matches in cross-validated data. I felt that recall was by far the most important metric, as I was concerned about my model's ability to accurately predict existing matches. And I felt that the additional cost of speaking with more venture capitalists would be very low, so I wasn't really concerned with the high precision. I did find my model had one weakness, which is that if the companies had no investors, I couldn't make recommendations. So I built a second model to expand the scope of the project. This second model uses NLP techniques to analyze the company's description. And for each of the, and from their description, I would tokenize keywords and project it to word vector space based on the co-occurrence rate of a common called corpus. From there, I could find similar companies from which I used to base my recommendations off of. I didn't score this model as I didn't expect the recall to be any good. Mainly because I don't think a company's self-description of themselves is a good predictor of who's going to eventually invest in their companies. I still wanted to build this model though to give a more diverse set of recommendations to be more useful to my user, which is startup companies. I combined both models under a user interface so that any startup can go through a series of questions and find targeted recommendations for them. My takeaways is that startup fundraising data is quite robust. I think this is a very strong strength for this industry. And so there's lots of problems that are primed for machine learning optimization. I think my models have demonstrated incremental improvements in efficiency and diversity of recommendations. And for me, the next steps are adding in information about team members, where they went to school, what companies they work for. I think using this information, I could build a new model that would be even more robust. Thank you. My name is Brendan, and it's my Capstone. Questions?
May I ask a question that's not directly related to the project? It's really good work. The question is like, I know Netflix pays very well, and they, you know, the analysts, I know they are pretty kind of full staff, right? They do all things from beginning to end. What drives you to come here and do this part-time while you already have a good job in Netflix?
It's just a testament of how much I believe in machine learning's future. I think it's going to be in every single company, touching every facet of operations. And I want to be part of that wave. So I came here to get more training to learn more. Thank you.
Hello, my name is John, and I made a Reddit comic classifier. So Reddit, for those of you who don't know, is a popular online forum. It's the fourth most popular website in the United States. In fact, it has over 250,000 new submissions every day. To date, it has accumulated 2.5 billion comments. For such sites, a major problem is moderation. The influx of new content outpaces their ability to moderate for malicious comments. So I thought I might make a model or a tool which would help moderators or help bring negative comments to moderation. I began with a data set which was made by some researchers at Google. They randomly selected 40,000 threads and annotated the comments in them. Unfortunately, they did not include the comment bodies or any metadata, so I set about reconstructing the data set on my own. As I said earlier, the set is rather large, 2.5 billion comments. So the first thing I did was make a scraper. The idea being I could figure out when the threads they chose had been submitted and use that to narrow down the amount of data I actually had to download. As it was, I had to download 1.5 terabytes and store that on an EC2 instance. From there, I spun up an Elastic MapReduce cluster, which allowed me to greatly narrow down the field to something you can actually use to train a model on. The distribution of the data is somewhat skewed. As you can see, answers make up 39% of all labeled comments, followed by elaborations, followed by none, all the way down to negative comments there at the top, which is the one I'm interested in. As you can see, there's also things had to be dealt with, the nones and the others. None means that the annotators answering the comment didn't come to a unanimous opinion, and other just a miscellaneous category. But this particular skew distribution would come back to bite me later. The first thing I did was deal with the nones. I switched from unanimous vote to majority and distributed accordingly, and then I dropped the others and started working on the actual comments themselves. I tokenized and lemmatized them, and then projected them into a TF-IDF vector space. Given the size of the corpus, that was rather large, 142,000 features. So I used SVD to narrow that down to the 2,000 most important ones. So back to these skewed comments. As you can see, I made two baselines. One which just guesses the most frequent label, that is, it says everything's an answer, and one which just makes a weighted random guess. And then I ran a couple of multi-class classifiers, very simple models, magnetic Bayes, random forest, statistical regression, and you can see they didn't perform that much better than the baselines at just predicting what kind of comment was in general. So for a binary model, I knew that I needed something a little more complicated. What I constructed was an ensemble. There are 3 tiers. The first tier is gradient boost. It separates out answers and elaborations from the rest and passes those remaining comment types to a theta boost, which separates out humor and negative responses and passes those to a gradient boost, which finally predicts whether it's humorous or negative. The final result looks something like this. As you can see, my 3-tier ensemble model has a lower accuracy than the 3, but it has a much higher precision. That is to say, the 3 top categories, the 2 baselines I made, and the other basic classifiers are very good at telling whether something's negative or not. They just say everything's not negative. The ensemble model has a very high precision, boosted up to 76%. And when it comes to making moderation tools, that's what you want. You don't want to inundate your moderator with false positives, saying all these things are terrible comments when they're in fact not. Anyways, I'm John. That was my Reddit comment classifier. Any questions?
I guess the first naive question is, how does Reddit do it today in that system? And is the 76% better than benchmark than what they have in the industry or not?
They do have their current system is just random reports. They don't have any different machine learning type of this. This would work similar to, they have an Automon system, but that does not use, that looks for terms that are user entered, and so that's not really Reddit wide. There's no universal tool I think that works this way, just to my knowledge.
You might call them.
Anyone else? All right, thank you very much.
Hello everyone, my name is Edmund and I will be talking about my work on predicting arrival time. The data I have for this project was consisting of 3 separate data sets. One was the static data set provided by the city to mapping services. That's the data you see when you tap on the directions of public transit. The second data set was raw GPS data that is data emitted by buses as they travel through San Francisco. And the third data set was the other data. It's an interesting problem to work on because it has been shown that accurate travel times promote adoption of services. So formally speaking, the problem that I'm trying to solve is to predict the arrival time of a bus at an arbitrary route, at an arbitrary stop on the route, given its current GPS location and historical data for that route. So the solution I went with was to first extract all the instances of travel times in each pair of stops on the route, train a model for each segment, and then in order to make a prediction, sum the predictions for the preceding segments from this route, from the stop where we want to find the arrival time for. In the literature, people have used other approaches for this problem. They use neural networks, time filters, and other things. So here's a more visual formulation of the problem and solution. The number circles here are the stops. So say we are trying to predict the arrival time of the bus at stop number 4, given that it's somewhere between stop number 1 and 2. We have the near real-time position of the bus from We would then get the prediction for the partial distance between stop 1 and 2. We'll get the prediction for the next segment and the last segment, and then sum them up, come up with the prediction for the arrival at stop. So something that took a major portion of project work time was extracting the actual travel time per segment. The raw GPS data was not very easily relatable to the static data, which was the initial assumption. So I ended up with a brute force approach where each stop's coordinates were compared with all the data that I had, and then approximate locations were found for the bus, and then the differences were taken those to find the actual travel time, approximate travel times between the stops. So this is just a screenshot of the route I focused on, long mission street, and the two blue dots are the routes I focused on. So the current status of the project is that I have a pipeline that is able to extract travel times, and then I'm able to predict travel time over one segment using 3 different models that I applied. The input to the models is for the variable that we're trying to predict travel times. We get that from the raw data, and then based on the timestamps, we use day of the week, day of the year, a month, etc. as input for the models. We also augment the input data with weather data. On that later. So what's left is to process the data for the remaining segments and to combine the predictors for individual segments so that we can actually predict arrival time and any arbitrary stuff. So here's an interesting thing I noticed in the segment that I was analyzing. I was expecting 2 peaks for morning rush hour and evening rush hour, but for this particular segment, it appears that traffic is very busy throughout the day. So here are the results of applying the models. Applying the weather data really is not much, and we only got about 15 to 40 to 50%, depending on which model we use, improvement over the. Some of the challenges with the project, as with most data science projects, was data acquisition and time taken in data processing. In this case, because of geodata, the time taken to process the data so that it's digestible by models was very long than I anticipated. I would like to explore how to use Postgres with its geographical information system extensions on AWS to speed up the geocalculations. And I would also like to optimize data processing and would want to look at XGBoost continued training features so that we can incorporate live data to augment our existing models instead of having data. My name is Evan, and I work on predicting travel time.
This is a super hard problem solving. Even the apps don't get it right or anywhere close to right now. If you could have any kind of data set you wanted, what do you think would you want to investigate?
So when you say any kind of data, I'm assuming you mean events data, what else is going on in the city at the time. That is something I would be really interested in finding out. And then, like if there are specific events, sporting events or otherwise happening in the city, how that would affect travel times. And I would also like to explore the effect of weather. Frankly speaking, that was very unsatisfying to see that the weather data actually decreased or increased the error. So that is something I would really like to explore as to why that happened.
Was there a seasonal component that you kind of observed over time?
Not that I could notice something that jumped off the page, but I did notice that for some reason, the month of October, the traffic flowed very well for this specific route. Perhaps didn't have enough data.
Did you find that some routes were more variable than others, and then was it? I'm guessing it was the variance increased the later the route was.
So I did not actually get a chance to look at any other routes. I only focused on the emission 14 route, just because processing the data even for 1 year of stops was taking a lot of time, even on a 64 CPU machine in AWS. So the idea was to come up with a pipeline that would work for the entire route and then scale it out to other routes. Thank you.
Okay, so I'm Chris Springout, and oops, that is not what I want to do. Okay. I'm Chris Springout, and the goal of my project is to forecast the population growth rate of all counties in the U.S. on both 1 and 5 year timescales. So people are interested in population growth for a variety of reasons, such as infrastructure planning, but the model that I created can also be adapted to forecast any target variable of interest that depends on county demographics. So the data at hand are taken from the U.S. Census Bureau annual data releases going back to the year 2000. And the methodology is, as shown on this slide here, where I used a random forest to minimize the RMSE on the quantity shown in green, which is basically the logarithmic version of population growth. So the model used as input features both the original set of features in the data table, but also additional features that I engineered myself based on demographic variables associated with the demographics of counties that are spatially nearby to the county of interest. So because I'm doing that, because I'm taking information from spatially nearby counties to the county of interest, this creates train test split problems because you might have 2 counties that are near each other, where if one isn't trained and one isn't test, then you have information between the 2. The exact same problem comes up with k-folding. So to combat that problem, I separated the country into about 100 different geographic clusters. And I did that using this modified version of k-means. And then within a given cluster, each county in that cluster would either always be in train or always in test, or always in the same k-fold. And so those clusters were then assigned to, at random, to 6 different groups. One group was used for a test, and the other 5 for training. In terms of the performance of the model, the simple baseline model that I assumed was a model in which the population growth rate from last year to this year continues at exactly the same rate for this year into the following year. And so these are the scores that you would get for that baseline model, and I plotted it as a function of population of the county, and unsurprisingly for the low population, and it's much more scattered than the high population. And then the lines with the stars show the performance of my own model, and for the 1 year forecast, there isn't all that much improvement over the baseline. In fact, as you get to the high population in the red, there's a 0 improvement. But for the 5 year forecast, there's a fair amount of improvement across the entire range of populations. In terms of feature importances, the features which tend to be the most predictive of population growth in the near future tend to fall into these 3 categories, none of which I think should be all that surprising. So how fast the growth has happened in the last few years at different time steps was predictive of what would happen in the future. The percentage of the population in different age cohorts was predictive, as was the current population. So I think I'm out of time, so I'll just leave my future work slide up here for you to read. I'm Chris Springout. I built a model which predicts county population growth for all counties in the U.S. Thank you.
Can I ask, like, if you're using a modified version of k-means to try to find out, try to divide kind of train test data set and validation data set, right? So, like, what benefit does it bring? I think you explained that a little bit.
Okay, so the point is that there's a lot of correlation between adjacent counties. In fact, I'm putting in explicit correlation because I'm saying I'm adding in features which have to do with what's happening in the surrounding area. So if you had, if you just randomly assign train and test to each county, then you have information you can back and forth between the to all over the place. So my modified k-means actually, all it does, one way in which it's modified is I'm creating clones of counties based on population. Because what I prefer not to have is a case where a boundary between these clusters is slicing right through a metropolitan area. Because one of the things is, are you near a major city? Are you near a major heavily dense area? And so if you're only able to look at things within your own cluster and the boundary line is cutting you off, it's cutting off a suburb from the main city, then that's a problem. So by doing it this way, I minimize that problem.
Yeah, I think that makes sense. I think what's this superior to the method of like just randomly choosing 30% validation?
Sorry, what is the?
Sure. So I think my understanding is like you're trying to use this, kind of plastering method to figure out what's your validation data set to see does a model perform well or not, right? Right. So what's this like? Why not just choose randomly 30% of counties as a validation data set? You don't train the model on them. You train the model 70% and validate on the rest 30%.
Because like I said, if you do that, you have information leakage between train and test. In other words, you want to know how well will the model perform on unseen data. But if you have something nearby, which has as an input information from the train, that will corrupt your test.
Okay. Thank you very much.
I'm just wondering why you chose the log ratio. What made you choose that?
Okay, well, I guess, it has the convenience that it goes from minus infinity to plus infinity, whereas if you take the percentage change, then it goes from minus 100% up to plus infinity. It doesn't really matter that much though for these percentages because they're not very big. So, probably won't get that much of a difference. There were a few exceptions, like after Hurricane Katrina, there's a massive population dip in certain counties in Louisiana. But for the most part, it doesn't really matter that much. There's another aspect of this, which is that I realized that perhaps for business applications, you might care a lot more about the high population counties, and this is treating each county as an equally weighted data point. So that's why in my future work I said one thing I could do is instead forget about growth rate, but just predict on the linear population, and that would weight the higher population counties much more. Okay.
I'm Braden, and I built a meal pricer with a company called Feastly. So Feastly is an online platform for chefs that host pop-up meals in cities around the US. And next week, Chef Fong's going to be hosting a 5-course Vietnamese meal in Nha Bell. And the question I was asking when completing this project is, can we recommend a price to Chef Fong? So should he be pricing seats in his meal at $36 a seat or $56 a seat? And this might make Chef Fong's life easier from the perspective that he doesn't have to think about pricing as much, and it might help him sell more seats. So Feastly gave me meal or event data, the things that were served at those meals, so dish data, cook data, where the meals took place, and purchase data since 2013. And my general approach was to think of each seat at a meal as an individual trial with 2 outcomes. Either the seat will sell or the seat will not sell. And so it's my job to predict the probability that a seat at a meal will sell. Because then I can use that probability and the number of seats at a meal to give the chef a nice visual distribution of how many seats they can expect to sell. So when I was building my initial model using logistic regression and random forest, I was asking, how can I best segment meals? How can I best tell a 5-course Italian dinner from an ice cream making event? And so I used raw values from the tables to build this initial model, like cuisine type and meal type and time and place of meal. This model did not perform well, did not meet my baseline accuracy score. So I kind of went back to the drawing board and engineered some features, 3 of which I want to highlight. So I did some NLP on text columns on my menus and dish table and came out with a dessertiness feature and features like that. But words like vanilla, cone, peach, and waffle were most associated with that dessertiness feature. I also created some hierarchical cuisine types. So every meal was associated with 3 cuisine types. An example of that is American food at the top level, then Californian cuisine, and then brunch at that bottom level. I also made simple counts of dishes, so how many appetizers were served, how many entrees were served, how many desserts. And my final random forest beat my baseline accuracy score by 10 percentage points. So if I had just predicted sold for every seat, I would have been right about 76% of the time. My model was coming in right about 86% of the time. The more relevant error metric in my mind was the difference on average between the actual percentage of seats sold and my predicted probability, and that was off by about 5%. And the coolest result is I have a working meal pricer. So this is for an Indonesian event in Naupel. And you can see at $42 a seat, and this is the recommended price, the chef can expect to sell 33-ish, 34-ish seats. It's kind of the highest probability, but if they bump the price up to $52 a seat, they're most likely to sell 23, 24 seats. My name is Brayden. I built a meal pricer with Beasley. Thank you. Happy to answer any questions if there are. It's cool if there are.
So if we think of price as being a function of how many seats sold, what I'm just curious about is why you chose to one method of the route you took rather than just a kind of optimization problem formulation.
Nice. So is this kind of getting at revenue optimization instead of seat time? Yeah. So I'm less familiar with Beasley's revenue model, so I don't have huge insights there. So I kind of focus on how can we get most people or the highest number of people at these meals.
But I was hopefully I got there. But is cost of inputs something that you were able to factor into this? Because the number of appetizers, the number of courses served could affect satisfaction. It might also indicate were you able to do anything around that, or is that data not available?
Yeah. So I didn't have costs. Estimating costs would have been interesting there, but maybe kind of those simple counts was already doing that. Yeah, I think that would have been a really powerful data. Especially, you probably don't want to recommend a price that causes the chef to lose hundreds of dollars. Thanks.
All right, folks, I'd love to give a huge round of applause to everybody that just presented today. That was incredible. I also want to thank our panelists for taking the time out of your day today. This is never, ever an easy or short ask. So thank you from the bottom of our hearts for coming and asking thoughtful questions. It really, really means a lot to all of us. So thank you. And everyone else, you're awesome too. Thank you so much for showing up and expressing interest and showing your support. I'm going to give you a huge round of applause. Let's go ahead and do that as well. And now is the fun part of the day. I have an events team about to wheel in some lovely food and beverages. I encourage you all to stand up and interact with each other, talk to our data scientists. I'm sure you all have a lot of questions that you want to have answered. And those of you that are considering joining Galvanize, find anyone with a staff name tag on. We're happy to talk to you about all the things that we do here. So we're more than happy to give you all that information. Let's celebrate, eat, drink, and be merry. Congratulations, G55 or G52. You're awesome. Sorry. Numbers. Congratulations, folks.
Science. Similar but not. You have a minute?